All right, good morning, ladies and gentlemen. Here is your quick review over the Algebra 2 readiness material. Basically, it's some factoring and one over order of operations. So I just want to touch on order of operations because a lot of people are still a little confused on this from Algebra 1, I guess, or middle school even. So, order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. So our first step is our first step is parentheses. We go and do anything within our parentheses. So I have an outside set of parentheses here. So I look inside there. Now, once I look inside a set of parentheses, my order of operations starts all over. So now I look for parentheses again. All right, now I have parentheses. Now I take care of what's inside there. Do I have any more parentheses? No. All right, and so next comes exponents within my parentheses. So I can rewrite this. 3 minus 4 plus 2 squared is 4 plus 5 parentheses squared plus 3. Now, again, inside the parentheses, we're still working inside our inside set. So 4 plus 4 is 8. 3 minus 8 plus 5 squared plus 3. Now I can distribute this inside of my parentheses, or essentially just take the parentheses away. Now, 3 minus 8 is negative 5, plus 5 is 0. 0 squared is 0. 0 plus 3 equals 3. All right, so those are your order of operations. When you're inside of a set of parentheses, you check again for parentheses. And then you go inside the set. Notice I didn't square anything until I had eliminated everything I possibly could. Also on that note, x plus 2 squared. What does something squared mean? So this is slightly different here, but while we're on this topic of squaring things, what does this mean? Well, I'll tell you what it does not mean. It does not equal x squared plus 4. This does not distribute like that. No. Something squared means it is something times itself. This is one whole term, so I have x plus 2 times x plus 2. And then there we FOIL. So we first, outer, inner, last. So our first two terms are x squared plus 2x plus 2x plus 4. So that gives us x squared plus 4x plus 4. That's what that gives us. All right. So moving on to factoring out monomials. So factor out the common monomial. You're just looking for everything that they have in common. And by factor, we're not dividing it out and it goes away. We just write out our prime factorizations. If you can't see it right off the bat, we'll write out our prime factorizations. That's just 3. I can go x times x times x, y times y. Because x squared, or x cubed, just means x times x times x, right? And y squared just means y times y. Plus, now our prime factors are 6. 3 times 2 times x times y. Now what do? I look for what they have in common. So I'll circle everything they have in common. So they have a 3 in common. They have 1 x in common. And they have 2 y's in common. So everything I circled, I draw first, or write first, 3x y squared, and then I do my parentheses, and then whatever is left, you can underline it, maybe if it helps see it a little bit clearer. I have an x squared, don't forget your plus 2. And now everything has been factored out that I can factor. Yep, cool, check. And that's it. That's your factoring out a common monomial. Let's do another one. Now, oops, select my pen. Alright, so I could rewrite 12 as 4 times 3 times x times x, 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 y times y, z plus 3 times 3, x, 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 y squared, oops, sorry, y times y, uh, times z minus, now our prime factors of 18 will be what? Correct. It'll be 3 times 3 times 2. And then I have x, x, y, z, z, z. I ran out of room there. All right, so then again, I circle everything they have in common. They all have a 3 in common. They all have 2 x's in common. Now, these have x's in common, but this only has 2 x's, so I can only circle what they all have in common, not just one of what they have in common or just all x's. It's only the number of x's that they all have in common. Moving on to y's, I have only one y in each one that has in common. And then for z's, well, there's only one z in the first one, so I could only take out one z out of all the other ones. So, what do I have left? I have, on the outside, I have 3x squared y and z. And then I just rewrite everything else I had left on the inside. Now, with these, you got to make sure you give yourself plenty of room and you don't forget anything. I'm working on limited space here, so 4, I have an x squared, a y, don't forget your plus, 3, x, y, z, minus 3 times 2, we can put that back as 6, z squared, it looks like, yes. And then we are done. And when you go back through here, there should be nothing that they have in common to still factor out. If you do notice something, you missed it, and go ahead and factor it out and add it to this. All right, so that's monomial factoring. That's how it should look on the quiz. All right, factoring difference of squares. So we notice here the difference of squares, the reason it's called the difference of squares is because your first term is a perfect square and your second term is a perfect square, and difference in math means what? Subtraction, right? So a squared minus b squared is the form it will be in. It factors just like this. A plus b, a minus b. And we can see the reason we factor it this way every single time when it's a difference of two perfect squares is because when we multiply it out, we get a squared, FOIL, right, first, then outer, minus ba, inside, plus ba, and then our last terms, positive b times a negative b will be a negative b squared. Our two inside terms cancel each other out, leaving me with a squared minus b squared. That is why they always factor that way, and that's what happens to your middle term, is it kind of just eliminates itself out. So let's look at this example, x squared minus 25. Now 25 is a perfect square. It doesn't have a squared term on it, but we could look at it like this. Now we can see our clear A and our clear B, and it'll just factor x plus 5, x minus 5. Again, difference of squares. I have x squared and 9y squared. Now, these are both perfect squared terms. We could look at it just like this. 3 squared, y squared. Now, from our rules of exponents, even if we want to clear it up a little bit more, 3y squared, we could pull that squared term out. Now, what's our a would be our x, and our b is 3y. So it factors as x plus 3y, x minus 3y. And that's good. And these steps right here aren't really necessary to show if you can just realize, okay, the square root of 9 is 3, the square root of y squared is y, and that. So we could look at it here. We'll do this one. So I have x to the 4th. That could be rewritten as 16 x squared squared, and then 36b squared, right? So if you have something to the 4th, think of it as that term squared squared. Uh, so now we can look at this and go ahead and factor it. I have square root of 16 will be 4. X squared, square root of 36 is 6b. And then 4x squared minus 6b. And you can always check your work by, multiplying it back out with the FOIL method. All right, factoring trinomials. We're on our last little segment here, and then we will be done. Factoring trinomials. Now, they come in the form ax squared plus bx plus c. Now, in this instance, for now, we're not worried about the a. The a we will hit on at a later time. I just need you to factor something like this. So factoring something of this nature, we're looking for multiples of c that add to subtract to give us b. So we could look at our multiples. Let's look at 6. What are our factors of 6? Sorry, we're looking for factors of c to add or subtract to give us b. So I have 1 and 6, 2 and 3, and that will be it. Now, we're looking for them to add or subtract together to give us 7. Now, there's a couple of things to note here. Our 6 is a positive term, as well as our first term is a positive term. Since our factors are going to multiply to give us 6, we know that they both have to be positive. Now, since they're both positive, they have to add to give us 7. Does 2 and 3 add to give us 7 or subtract to give us 7? Either way, no. 6 and 1 will. Those are our factors. We'll go ahead and look at another example. So factors of 12 that add or subtract to give us negative 1. Now this is a positive 12, so we know that our signs have to be the same. So we know we're going to have the form x plus something, x plus something. Now, this middle term is negative. And so let me ask you this. Is there any way that we can have two positives and get a negative? That is a no, right? So what we have here is no solution. When you get here and you just think logically about it, these both have to be positive, this factor and this factor. And I have to add them up to get a negative number. That's not possible, so we have no solution. And going on to this one right here, I have x squared minus 6x minus 16. So our factors of 16, negative 16. So since this is negative, we only multiply two negatives give us a positive, two positives give us a positive. So we know that the signs have to be opposite. With that being said, our factors of negative 16 are 1 and 16, 2 and 8. What else? Yep, 3 is 6. And then 4 and, 4. So now again, I'm trying to have a positive and negative that add or subtract to give me 6 and multiply to give me 16. Well, 16 and 1, any combination of those give me 6? 16 minus 1, no. 16 plus 1, no. 1 minus 16, 1 plus 16, no. 2 and 8, well, I believe we can. If I have now, negative 8 and a plus 2, they multiply to give me 16, subtract to give me 6. Those will be our factors. And that is it. I hope you enjoyed that brief little review. Enjoy the rest of your Sunday, and I will see you in class Monday or Tuesday with a brief quiz over this refresher material. All right, have a good weekend.